team to confirm about this.
Oh,
Okay. So, hi everyone. Let me introduce myself. I'm Lavisha Basantani. I'm the head HR at DIYguru. I take care of all the trainings and placements at this institute, and we are into the EV and e-mobility training institute, as you all know about DIYguru. And today's session is about the future is electric, exploring careers in electric vehicle technology. This is the topic for the day, and we'll be starting the session within 5 minutes. Thanks for joining. And if you have any questions, if you want to interact something, if you want to have any clarifications to your doubts, you can ask in the Q&A session, that is for last 15 minutes. And apart from this, if you want to ask from me anything, you can just drop into the chat box. Yes, David?
I'm sorry. I wanted just to put an emoji. I
It's okay.
raised
It's
my
okay.
hand instead. I'm sorry.
No issues.
Please tell me that if this is the same what we were asked to join the webinar on retrofitting of four-wheelers.
Sorry?
Is this session regarding the retrofitting of four-wheelers? Is this
Yes,
this
yes,
is the
it
webinar?
is. It
Okay,
is, yeah.
fine.
So our speaker will be joining soon, and I guess by 7:35 we'll be joining the session. Till then, can I please know from where are you guys joining today? You can drop your city, your country, your state, anything in the chat box so that I can know. I am from Delhi. Delhi is the headquarters of DIYguru, and you
Hello,
can
ma'am.
Delhi. Oh, Satyam.
Hello, ma'am.
Satyam, are you the same person we met in noon? I was checking the session.
Yes, ma'am. Yes, ma'am.
Okay,
Yes,
hi, nice to see you here. December, Bangalore, Pune, Bihar, Algeria, Chennai, Indore. Oh, my hometown is Indore. I'm from Indore, basically. Andhra Pradesh, Varanasi, Delhi, Hyderabad. Okay, we have students from Pan India, I guess. Very nice. Bhopal, Andhra Pradesh, Jodhpur, Uttarakhand. Okay. Nigeria. Very nice.
ma'am. Nagpur.
Oh, there are so many chats I can't read even. Indore, where? Okay, I live in Indore near to Silicon City, at AB Road, and I'm working here in Delhi, Aurangabad. Okay, Solapur,
Ma'am,
Nepal,
you are from Indore or Pithampur?
Indore, proper Indore. AB Road, the way that goes towards Rao. Siva, yes, please tell me.
Ma'am, can you tell me about the procedure of placement?
Procedure of placement. Okay, so the procedure of placement that we have here at the DIYguru is we bring down the opportunities for our students that is screened down by us. We either visit to the company or we discuss with the HR, and once it's done, we post the job description on our LMS portal, that is courses.diyguru.org, and from there you can access to the jobs whatsoever you are interested in. You can just apply to it. We'll be screening your resume. If your resume is having any shortcomings, like it's not good in format, or we need to change the photograph or LinkedIn URL, anything, I'll be reverting back to the mail itself, and then we'll be sharing your resume to the recruiter. They will be continuing ahead with your interviews and all. Okay, so if anyone is there from DIYguru team, do we have the speaker with us? Can I transfer the call to him? Pradeep, Dinesh, you have a lot of questions. Okay, one by one, you can unmute yourself and you can ask. And if there is something like Q&A, so you can wait for the end for ending this session.
So what are the opportunities for the placement for working professionals?
For working professionals, we also do have opportunities. The ratio you might consider between 60 to 40. 60% is for 60% is for freshers, and 40% is for experienced. And we do consider the opportunities which will be considering your past automobile experience or your past mechanical experience into this. Okay, so I guess Mr. Jawad
Having
is
the
here
on
with
the
us.
electronic.
Hi, Lavisha.
Hi, how are you? Good evening.
Good evening. How are you? I'm fine.
Okay, great. So, students, we have Mr. Jawad with us. He'll be continuing up with your session. So, I guess I can hand over this call to you now.
Sure. Thank you so much, Lavisha, for the introduction. Hello, everyone. Good evening.
Good evening, sir.
We will start the session today. Before that, I think, is there more people who are joining? Or is it?
We can start. We have 120 plus participants. You may start.
Okay, so before I start,
Lavisha ma'am,
Yes.
ma'am, recording video will be available after the completion of session.
Recording is done, but is it shareable or not? That my team will discuss and will let you know. Till then, at least I guess we should start with the live session because he is here for a limited time. So I guess we should utilize it first, and then we can discuss everything into the Q&A. That would be in last 15 minutes. Yes, please. Sorry for the interruption, Mr. Jawad.
Dinesh, no worry. You can connect me on LinkedIn. I can, if there is any question, I can answer you. So we start with the session today, and I will share my screen. But before that, I think all the people who have joined today's session, it is more regarding the retrofitting and about the EVs. And I think you all have the knowledge of EV basically, because if somebody is not with that, then it will be a little difficult for them to understand what exactly this industry is. So I will share my screen and hope you will get good knowledge and good clear, I can say, the tech, what exactly it is. Sure, Rafiq, I will tell. I will tell all the things. Let me share my screen. I can tell you what exactly today's session will be about. So, Lavisha, is it visible and my audio is audible? Like everybody can hear?
Yes, you are perfectly audible and your screen is also visible.
Okay, if somebody lost me, please let me know. Maybe there is network issue. So is it visible? So I'm sharing my screen. So today's topic is about the retrofitting of the four-wheelers. And if I tell you about what exactly it is, I have to just go with the very basics. What does a basically EV mean? Everybody is comfortable in English or Hindi? So I will go with both to get things more clear.
Sir, please prefer mixed language.
Oh, sure, definitely. मैं दोनों के साथ
We can mix the language because we do have national plus international students, so everyone would be able to understand.
Yes. That's why I just saw.
English would be okay for everyone.
Yes. So the today's session, the content, the table of content for us today is that what does the EV basically means? What is the retrofitting? Retrofitting, how it is, come into the market, how it come into the industry. We can go with the overview of the IC engine to the electric, because retrofitting is more about the existing vehicle to converting it to electric. So that is one thing. We will go with the technical aspects, because technical aspect means how things has to go with the the motor, controller, everything, how it has to be go with the numerically, the theoretically with the vehicle, because we have the big challenge that is to convert a old petrol, diesel, even CNG car to electric. We'll go with the battery system, and this is the most challenging thing in the whole EV. Either it's a new, it's a retrofitted, it's a bike, two-wheeler. This is the most challenging part, and it's the most expensive part in the whole EV. Then we go with the performance and efficiency, how it perform, how the efficiency go, because the vehicle which we have to make, it is more about the performance, because hame gaadi banana, it is not something which we can do it, because if you go with the you just open the YouTube and search there the how to make a petrol car to electric, you get a lot of content about this thing, but that we call a jugaad. So we have to go with all the things, how technically all these things work, how the science, how the logics work with this. So we will go with this whole system, and then the safety and regulatory consideration. And this is I can see the most crucial part, because nobody talk about this, because what we call it ki battery, motor, controller जोड़ना उससे गाड़ी electric होगी, that is not something which we can talk about, because the safety and regulatory is the more important thing right now. Environmental impact, definitely we are talking about the EV, it is having a good environmental impact. We will just go a little more deeper in this. Cost analysis, because if we want to go with this business, this industry as a big scalable industry in the future or even currently, so what the cost analysis is, and then we'll go with the case study, that is our own the tadpole, like how we work on a one product, and that I can say, and after that the question and answer. So I think the table of content is clear, but before I start with this introduction and all the other topics, you have been go with about the EV content, what exactly it is. So if I start with this thing, why we convert the IC engine vehicles to electric? This is the more important question currently. And if I talk about what exactly it means, is that every time we talk about the people, or we talk about the people who are talking, who are generally the media and everything, we're talking about the EVs. Tata has made new EV, Tesla has made new, even Honda has made new EV, but we never talk about the old vehicles, because if a person is owning a petrol car, if a person is owning a diesel car, what about that one? We are not talking about. We are talking about the new industry. We are talking about the new tech which is coming to market, but we're not talking about the those vehicles which are already in the market. दिल्ली के अंदर की अगर बात करें, 1 करोड़ से ज्यादा गाड़ियां हैं, तो उन 1 करोड़ गाड़ियों की हम बात ही नहीं करते हैं. That is the one point. And the other thing is the importance of reducing carbon emission, because the vehicle which is currently inside the city, अभी कोरोना में हुआ क्या था कि सारे गाड़ियां जब बंद हो गई थी, तो हमने दिल्ली और बहुत सारी सिटीज के अंदर हमने people start making pictures, and they start uploading on Instagram and Twitter that this is the clear sky, Yamuna साफ हो गई. So carbon emission is the important part, because it plays a very big role, which will go into the next slide, and there we can see how it impact. So बात करते हैं कि IC इंजन व्हीकल को पेट्रोल इलेक्ट्रिक में करने की सबसे बड़ी जो हमारे
communicate in English, sir. Why you are
okay no
yeah, we are all from South India. Okay,
no issues. So we will just start with that. Why we have to convert the IC engines vehicles to electric power? Why there is a need? Because everything which is in the market, it comes with the need. Because if we are making currently right now a new device, new technology, that it comes with a need, and it comes with always a problem. So yes, it reduces the environmental impact, because if we talk about any vehicle, let's take an example of Swift Desire, it is emitting 3.6 gram of carbon per kilometer. So we whenever we drive 1 kilometer of any petrol car with a 1200cc engine, it emits 3.6 gram of carbon. That is one part. And the other part is not only the carbon dioxide which is in the environment. There are the nitrogen oxide and NOx and the other particulate matters which are currently in the whole city. If I talk about especially Delhi, where this is the most most, I can say, the viral city in if whenever the Diwali comes, so we see a lot of news about this city. And the energy efficiency, because if we compare it, the other part is the energy efficiency. If we compare it with the petrol to the electric, we see a big difference, because it is a very logical, and it is very, I can say, you have all the people have experienced this thing, that electric cars, electric vehicles, either it's a two-wheeler, three-wheeler, four-wheeler, they have much power and much better efficiency than the fossil cars. And the other is the cost saving. And yes, it is very clear that if we drive a electric car, if we drive any other vehicle, we make we save a lot of money, because running of the cost running for a one vehicle for an EV is 1 rupee, even less than 1 rupee per kilometer. So that is the big difference if we talk about with the conversion of IC engines to electric. Then another point which we have is that the quiet and smooth operation, because the vehicle which is in the petrol, diesel, they are making a lot of noise. When we convert it to electric, they are very smooth and they are quiet. Basically, whenever I talk about the EV and whenever I talk about the retrofitment, these two are the same. You have to always remember this thing. Retrofitting doesn't mean it is some new tech. These both are same. Only the difference is the chassis. In the new EV, you have the chassis there. In the retrofitment, you have the chassis already there. In the new EV, you have to make. Only difference in this technical term, I can say. Energy efficiency is definitely there, because it is the the electric motor are more efficient than the combustion engines, and the significant amount of energy, significant amount of production of electricity compared with the burning of fossil fuels is more. So we can have a better efficiency energy in terms of the terms of reduction, in the terms of the power propulsion, and the energy independence and security, because electric vehicles can provide powered with a variety of energy source. Because if I talk about the IC power car, there are three options: petrol, diesel, and CNG. Even some LPGs and other gas we can have. But in the electric motor, if I talk about EVs, we have a lot of options. Yes, the source is electric power, but we can get it from the solar, we can get it from the wind, we can get it from the hydro, we can get it from the coal, we can get it from the nuclear. So these are the different kind of independence, because we are not dependent on one kind of fuel. And the technological innovations, because in the EV we have a lot of tech. If we talk about from the past 10 years, we have seen a lot of difference in the EV, especially in the tech part. We started with the single gear, we have the four-wheel drive, we have the crab walk kind of vehicles, we have the lot of tech. We started with the, if I talk about in India market, we started with the 48 volt. In 2013, Reva came with with few EVs which are E20. Mahindra Reva, then Mahindra bought it in back 2014, I guess. So they came up with 48 volt of system. So we have a lot of technological innovations. So these all things which I'm talking about, it is basically why there is need, because anything in the market, it comes with a need. Without need, without a problem which we have to solve, these things never get mature, and the things never get a big opportunity. Because from the past 200-300 years, we are burning fuel every day. We have made our planet a very, it is not better for living for humans. So now we talk about the greener energy. We talk about a lot of, carbon credits. We talk about emission reduction of the carbon gases, carbon emissions. So then it is something which we have done it in the past. We are looking for something currently. And these are the solutions which make our whole ecosystem better. So this is some introduction why there is need for this and how we have to solve the problem. Now we come up with the IC engine overview to electric conversion. So basically how IC engine involve, what are the components inside the retrofitted vehicle, and how we can convert it to IC engine to electric. And also we will see what are the benefits of electric vehicles compared to the traditional, as I said in the past slide. So we will just go through these slides and we can know how it works. So now I have to make a electric car. Let's take an example. We have to work on Honda City or any other vehicle. So first of all, what we do, I don't have to open a YouTube and I don't have to go for how to make a Honda City petrol car to electric. No, that is a jugaad. I can say that is a total jugaad solution. That is a jugaad approach. We don't have to go with that. We have to go with the proper approach. So first of all, we will do the assessment and the planning. First of all, we go with the what kind of the specific model we are looking for, how it is feasible. And the live example I can see currently is that we go with this phase where we were converted the Mercedes C-Class to electric. And that is something very challenging because there is no petrol, there is no space for the batteries. And it is very challenging because it's an all sporty vehicle. So that is something, the feasibility, the assessment, we have to go with which kind of specific vehicle model we have to go with, we have to start with. And the other thing, how we work is that the factors, the age, the conditioning, the weight and space availability for the batteries and electric component. These are the approaches basically Tadpole works. This is how Tadpole starts the things and how it go with the proper model and how it works. So when we go with this basic, like what kind of vehicle we have to convert and what kind of, what is the vehicle age, what is the condition, is it trusted, is it, the drivetrain, the tires, everything is okay, is it smooth or not, and is there a space for batteries? That's the most important thing, because we have a big challenge here is that we are working on the retrofitment, and in the retrofitment there is no space easily you will get for the batteries. If you are making a new car, there you can design the space as per your battery size, but here you have to make the design something which we can develop, which we can integrate inside the vehicle. And after that, we have to determine the goals, exactly what we have to do, what we have to make from this. Because we are not talking about a college project. We are not talking about some kind of video which we can upload in the social media. We are talking about a proper business. And going to the component selection, I will just go with my what I do, what basically Tadpole do. So I started Tadpole projects in 2020, and till now we started with a vintage retrofitment. So we converted the first vintage car to electric in IIT Delhi, and after that, till now we have converted 15 vintage car across the country, and also recently we have worked for the Indian Army and delivered the gypsies to them. And this is something first time in the Indian Army, the one startup has given this kind of solution. We also give our solutions to national parks, and also we had a big collaboration currently with the fleet operators. And we were also a technical partner with the Action Construction to develop 30 ton of electric crane. We are not the first one in this market, but yes, I can say we are the first one who started the new industry, new approach with the good results. And we have the challenges every day, and this is I'm just talking in this session. I'm talking about how I think how Tadpole work and how we take this thing, work on a model, and how we take things very I can say the clear manner in a particular steps to make it a sustainable, viable, and scalable business. So coming back to the component selection. So component selection, after that, when you have the assessment and planning, which kind of vehicle we have to go with, and then it comes to the component selection. And there is the main important thing. You have to select an appropriate electric motor, which means there are a lot of options in the market. If I talk about the motors, if a person, many people know about the motors, but for the other people, I can just give a very small brief about the motors. A motor is basically which converts the electric power to mechanical, and there are a lot of options in the market. Usually for the electric vehicles, we go with the induction, we go with the BLDC, we go with the PMSM, and currently the SRM is in the market. So these are the latest tech which I'm talking about. Although it is a very vast project, and you can read it on Google, and you can have a better knowledge from that. So once the assessment and planning is done, we go with the motor. What kind of motor we have to use, what kind of size, what is the desired performance characteristics. So if I have to work on the Honda City, so first of all, from my mind, I have to make this Honda City either better than the petrol Honda City, or I have to make it similar to the electric Honda City. So first of all, that thing has to be very clear and sorted. It is not something which we are making Honda City to a e-rickshaw. So that thing is very clear. And after that, the second thing is the what kind of range I have to go with. If I go currently in the market, if I compare my vehicle, with the, for like a Honda City, if we have to make it electric, we will go with what kind of the nearest electric vehicle which come into this radar of sedan. So Tigor is there. We can have when Mahindra Verito is there, e-Verito. So there we can have a range of 130, 160 kilometer. That in between we can have the range. And the same we have to go with, because if we can't give the better, but if we have give the similar range which is currently available in the market, because the customer acceptance is as per that. So we'll choose a sustainable battery pack which provide a sustainable energy capacity and the voltage and the range definitely. And here is one more twist. When we talk about the battery and we talk about the motor, so motor we have the PMSM, induction, the SRM, BLDC. In the battery pack we have the lot of choices. Like definitely we will go with the lithium pack, lithium battery. But in the lithium there are LFP, NMC. There is one more chemistry, LTO, graphene. This is another chemistry. It is not from the lithium, but in the lithium there are these chemistries which we have. The options are, so we have to go with that. And voltage, why there is the voltage I have written here, the voltage plays a specific role, because if you go with the let's take example of Tata Tigor, we have the 72 volt system there. If you take an example of the new Tata Tigor which is in the market, even a Tiago, there the voltage is 384 volt. Now the question arises, the same vehicle with the different voltages, how what does this mean? It is very basic. Like you go with the the losses is in electrical terms we talk it is equal to loss is equal to I square R, IR square, sorry. So basically it is the more current come from the flow from the wire, the more it get heated. So voltage play a very big important role here. What kind of voltage we have to choose? So we choose with the 72 volts. Then we have to go with the components. What kind of controller we have to go with? What kind of charging system we have to go with? So our approach here, when we have to go with the component selection, we have to very clear that we have to work same what our OEM thinks. We have to make a vehicle which is already in the market, similar to that. Below that, there is no sense to making a vehicle, because customer perception is something you will deliver him a brand new vehicle with that performance. So below that, there is no sense to make a car electric as a commercially. Then we talk about the integration and installation. So the integration installation is a very important thing, and it is something which where your designing skills and to be very honest with you, whatever I'm talking here about the assessment, about the component designing, it is not a one-person game. It needs a different domain of people who can work on the different parts, who can work on the different things. But yes, you can have the access and the knowledge of all the things, how it works basically. So the integration installation is basically how you can integrate motor with the gearbox. You have to run your motor, your vehicle on the same gearbox, either you have to make a new gearbox, and either you have to make the direct shaft. So in our case, in the Tadpole case, we run the vehicle currently on the manual gear. And the reason for that is that for the gypsies, which we deliver to the national parks and Indian Army, there the need is that they want a 404 transmission there. So for that, we use that gearbox. We integrate that gearbox in the very similar way how engine behaves. Our motor mimics that thing. So I can't share the pictures here because it is for the patent. So for that reason, I have not added the design here. But you can I can give you the idea in the upcoming slides. And about other things that chassis part, that how we have to modify the chassis, because it's a packed chassis where we have to cut, where we have to put a drivetrain, where we have to put the batteries. That is the important, very challenging part. Because let's take example that if we have to install a 23 kilowatt of battery, which means 72 volt 300 Ah. So where we can place that battery? Either we have to space there. No, there is no space. So how we can install? There the designing come. You have to go with the designing part. Where we have to place that thing. You have to go with the 3D. We have to done the 3D of the vehicle. Then in the SolidWorks and in the basic software is the SolidWorks, where we can just go where we have to exactly place. The designing is done by us, because in the market there is no batteries for the four-wheeler which you can get easily. So you have to go with a good battery player, and you have to design by yourself. Then it comes with the wiring and the control system. And this is something where every people, they just, I can say, miss this part. It is something kind of an English paper in the board exam where people think we can get, we will pass it very easily. But no, wiring and control system plays also an important role, because if the wiring is not proper, if the wiring is not as per the capacity, it will melt easily. There is a full, I can say 99% chance for a shock, and I am the victim of that shock, because there is one wire from the contractor to the controller. There we use the 16 mm wire, and logically we have to use the 70 mm wire there. So that wire melt, and I get the shock when I open that box. So that is something why I'm talking about the harness, because in harness is something when a motor is at the full peak power, when you are just drawing the full peak from that, there the motor behaves double of its capacity, and the flowing of current is at the very high rate, and you need that thing. The wiring is definitely as per the calculations what you have to go with, and it is not only for the motor, it is for the battery pack and the other subsystems, because it controls and ensures the functionality of the performance. We are talking about the EV, and the wiring is the backbone. And then it comes the most important thing which I mentioned earlier, that is safety and compliance. If you have to make now the question arrives here that, okay, there are a lot of players in the market who talk about EVs, we make the electric car. In the YouTube, you see a lot of players, they said, okay, convert your car to electric. This is the battery, this is motor, I have done this. But when you make your vehicle to electric and you just, take it for a drive, your vehicle will get seized very easily. The reason is it has not done the compliances. Any vehicle, any kind of car, vehicle, anything, four-wheeler, two-wheeler, if it is in the Indian market, also in the other market, European market, UK market, they have to go with the safety and the compliances, which means they have to go for the homologation, the certificate part, which in India, it has been done from ARI and ICAT, and then there are a lot of other agencies also, which take a lot of money. So the vehicle you are making, it has to be as per AIS 123. You have to, follow all the ISO standards. You have to follow all the tests. You make your vehicle, you give it for the ICAT, ARI. There you have to give the 20 lakh rupees of fees per model. And then you will get a certificate that this vehicle has been certified under the ICAT and ARI. And then you can register your vehicle under the RTO. Here, most of the people fail. Because we make the car electric, for the IC engine, there are 30,000 parts. And for a electric engine, electric power car, there are only 10-15 parts. So anybody can make, for the even engine, there are, 500 crore, 1,000 crore of investment to make a one engine. And for the motor, there is no, you can get it from any big player or any good player. So making electric car, it looks very easy, but when it comes to the safety and the compliance part, here everybody fails. Because you have done the jugaad from the starting, and here jugaad don't work. Here your engineering, your calculations, your performance, even a single switch you have used, that works. And when you've done the compliance part, then it comes the performance testing. And now it comes the another big part. That is, in Hindi we call it doodh ka doodh, pani ka pani. Because customer is a judge. You have spent a lot of money. You have spent a lot of time. You have choose one model. You come with that part. But then customer is going to use that part. Like you have to sell that car. You have to sell, you have to make your customer car to electric. And then the customer is your king. He decides, is this vehicle worthy or not? If the performance is not good, if the testing optimization is good, then it's a failed product, although you have done the compliance or not. So from the starting part, from here, assessment and planning, this is, I can say, 80% of your work. Because without that, all these steps are, doesn't make any sense. And when you do this performance and testing, then it comes another part, which is the documentation and certification. And this is something which go with the RTO level. Because when you go with also the RTO level and with the customer level, after getting the ICAT and ARI certificate, you have to register your vehicle at the RTO level. From where a state, district level, RTO can register your vehicle with a new number plate. And there is another category called XEV for the vehicle which you retrofit in the government with the, the Gazette, which has been released by the government, AIS 123. Which is the compliance basically. So there in the Gazette, there is very clear mention that the vehicle which you convert, they have given the new name for it. It is called the XEV. XEV, why? Because it was first petrol. Now it comes to electric. So it's a XEV category. So retrofitment basically means the XEV category as per the government rules. And once the certification, the registration RC is done, then you have to go provide with a basic knowledge to the customer, how the component specification, the logbook, the book in which all things are mentioned, the wiring harness, the component selections, the necessary and the certification regularities, all the things have been covered in that. So when you go with all this thing, now customer has taken the vehicle is good, the performance is good, the compliance are done, then it comes another important part, that is the maintenance and support. And we are in this country where the people need the value for money. If there is no maintenance support, still your product is failed. So you have to go with the proper maintenance, proper support. You have to go with the tracking of the vehicles through IoT. And recently we have worked on our own system. We track the vehicles which are running. We read the pattern. We are working on the few AIs currently in which we can predict the fault. Because running of the vehicle is important. And if your support is good, your maintenance is good, then you have made, although it is not Tesla, but you have made a Toyota. And your goal should be very clear that don't repair until it is not broken. This is basically a Toyota, I can say the slang, but they always call it that don't repair until it is not broken. So same thing, you have to go with your tag. You have to be very confident what kind of motor I have done. It is as per the logic, it is as per the tag, it is as per the things which I'm talking about. Then the next part, the introduction, the next part come about the compatibility assessment. Basically, when we session, I'm talking about these things very in a more I can say deeper way. So here you can see the gypsy which we have converted. It is a very rough diagram here. It's a very SolidWorks 3D. So you can see here that this is the motor here. If you can see my cruiser here. So this is the motor which you have coupled with the gearbox, and this is the a fabricated box in which the control every part is there. And here you can see the battery pack is something which we have placed here. And the people who know about the gypsy is on the ladder. It's a ladder kind of chassis in which there is only space here, either here or either in the front. So front part we used because the requirement of the client was to make it 4x4 as well. So this vehicle is running on the electric gear and it is running on the 4x4 transmission as well. And the battery we have placed here, we have designed in that way that the weight of the vehicle should be clear, should be balanced, and the height, width, and everything has to be very clear. So in the next slide, I have given about the designing of the battery, which we have done for the Gypsy. So it is mentioned there. So you can just see from this 3D how the things work. It is not something, total jugaad you can do. You can click the picture. You have to go with the proper single detailing of the vehicle. When I talk about the vehicle condition age, the chassis body, it plays a very important role here also. In this thing, if you just take an example that this part, the fender side, the ladder side is not good, then this battery will get damaged very easily, because this battery for the Gypsy fades 180 kg. Yeah, there is one more thing which I forgot. That is in the AS, you can only add the weight 25% of the vehicle. Like the unladen weight, if it is 1000 kg, the government only permits you to increase the 25% of the weight of that vehicle. So the designing, everything has to be clear as per the rules. And now if I talk about another part, that is the bearing, the tire, the chassis, because making a new EV is easy for me, but if I think to work on an old vehicle, I think it's the most challenging thing in the world, because you don't know about the tires, you don't know about the chassis, because everything has driven for lack of kilometer. So this is the most challenging industry currently, in which we have to go with a good product and good parts. Here I can give one of my experience, that when we deliver one vehicle to in a park, there we see that we tested the vehicle here, and there after some time, around 15-20 days, the vehicle is not running. The person who was driving the vehicle, he said that whenever I'm driving the vehicle, it gets turned off very easily. Like it is getting the battery is getting disconnected whenever I press the pedal. So the maintenance sport part, there it came. So we were very surprised at how this thing is coming up. We have tested the vehicle. Then from here we can't say anything, because that time we have not developed any IoT, any telematics from where we can track the data. And we went to that place, and when I drive the vehicle, whenever I press the pedal, it start taking a little acceleration, and it get disconnected. And when I connected our whole system with the through CAN, where we can get the data, so everything was okay. There is no, I can say, nothing where I can suspect. We check the whole battery, whole motor, whole controller. We are not getting the fault where it is coming from. And then I just go with the very basic. Okay, let's take this vehicle from the starting. How we make. We check the gearbox. We lift the vehicle first. We check the gearbox in the neutral. It is running fine. We check the transmission. It is running fine. Then I called my one engineer. I told him that, okay, take this vehicle on the jack and run its tire for at least 40 minutes. So when I start running, there we see there is a lag in the tire between, from for left side. And the RPM is not matching the tire which is for the right side. And here I get I suspect that there is something in the tire. So when we open the tire, we see the bearing was totally faulted. So the bearing was jammed, the tire was jammed, and it is why the motor was disconnecting again and again. Because I have set all the, I have limit the currents, all the peak current, peak power in such a way that whenever there is so much load, the motor will automatically get disconnected. So there you find the fault in the bearing. So that's why this thing very is important for us, that the vehicle condition, the chassis and the drivetrain components, it is very important for us, because we're working on an old car which have been driven for lack of kilometer. And the space, it is definitely the battery we have to keep, because there is no space. And in the Gypsy we have not, there is, I can say, not even a 1 inch for us where we can increase our battery. So that is the thresh where we have make our batteries bigger in the size and bigger in the capacity. So that is the important thing also. Another thing here, is the weight distribution and balance. Because if your whole system is at the back, the battery is at the corner, and from the front side the components are not that heavier, then there is the hammer effect in the vehicle. You can see the hammer effect whenever the especially in the seesaw like kind of thing, when we drive the vehicle, there will be the hammer effect. And it is because of the battery pack, because I told you the battery pack weighs around 180 kg. So that is not a joke. It's a very heavy. And it's the same for that capacity is the same for everybody. So that is something which you have to go with the distribution of the weight, because you have to check my CG, center of gravity, is good, my rolling resistance is good. Is it making worth to make it electric with this design, or is it something, a burden I have put it on the body or on the vehicle? Another is the drivetrain configuration. I told you earlier that how you have to connect the motor with the drive wheel. Either it's a front drive, it's a rear drive. You have to, if you want to use the gearbox, you have to go with that coupling, where we call the flange coupling. But you have to design that part. You have to just mimic how motor behaves. It is something, I can say, the trick which we have, which I know. Just replace the motor in the similar way as your engine behaves. And another thing is that the layout of your electric motor design, everything, how it works, how it will get coupled, the clutch is there. If you want to use the drive for the single gear system in that, make it a full automatic, you can do that as well. But I told you, it totally depends on the client and the type of the vehicle you are working on. Now, there is one more thing in that vehicle. When we, the experience I'm sharing is that when we check the tire of the vehicle, we find that the bearing is totally damaged. But there is one more important thing which I noticed during the data which I was tracking, that the temperature of the motor goes above the 100, and the controller temperature goes to 60 degrees Celsius, which means this vehicle is getting heated. That time we have not done any cooling system in the controller part, because we were working on a very basic. We just think, okay, it can run. But it was basically a hotter city, so the temperature is very hot. And then we find that, okay, what is happening there is that when we are driving the vehicle in the first 40 kilometers, it is running very fine. But after that, the whole performance efficiency is down, because the controller is making its efficiency down because of the temperature. So temperature plays very important role. So you have to go with the cooling system. We develop our one system, we install the cooling pad there in the controller and the motor. From there, the controller temperature, like especially in Delhi, there was 36 degree outside, and our whole EV powertrain system temperature was 28 degrees Celsius at that time. So that means it works and it gives a better performance to the vehicle. So that is something which we have to work on, the cooling and ventilation, because it's a very important thing. It is not something engine which requires 600 degrees Celsius of temperature. No, the cooler and more ventilated your EV powertrain system is, the more efficiency and more performance you will get. So that is the learning which we get from from our basically faults which we done in our past, but that gives us a good result. And I'm sharing my experience with you so that you can also go with these things in the similar way while designing a vehicle. And the fuse system, connector system, it plays also, I can say, very tricky role here, because generally when we go with any controller or any motor, the connectors are basically from the vendor side. From, like, if you are taking a Kirloskar motor, if you are taking any motor in the market which is meant for the EV, even for any control like Curtis, the Zappi, any controller. So the connectors are basically from the vendor side, and we never, check them, and we just use them. But, the connector plays also an important role here. It is the same case which I, another experience. There is one vintage car which we have given in another city. So there the vehicle is not, getting started. So when I visited the site personally, there I find that the connector is broken. And why it is broken? Because it is not of the automotive grade. So connector and fuse plays very important role here. The wiring, obviously it plays, but these small things, because for that one connector which cost only 5 rupees, I have to spend a 50,000 for my flights, like spending hotel, flight, 2-3 days stay. So that cost very big for me. So there is another learning which I got from the real experience, that connectors you have to go with the automotive grade. Either your vendor is providing, but you have to check it is worth it or not. And when you are talking about the upgradation modification for the higher voltage, higher current, you need the another components. Look, DC direct current, AC alternative current. If I talk about which current is the more dangerous, the answer is DC. But if the voltage is high, in the AC you will get a chance, you get free. But for the DC, it will just make your total, I can say it will make a person total melt into a whole, in a carbon state. The DC is very, and in the batteries we are using the DC batteries at a higher voltage. So the component, the protection for that, you have to go with that. And if we go with the back data, we saw a lot of news about the 2-wheelers, 4-wheeler, that the battery are getting short, the fire incidents. So there the BMS plays very important role. So look, in this session I'm not going with the component level, what kind of component we have to use, I'm just going with the real world challenges, the integrations, and how we had to go with this whole ecosystem. So then AIS 50048 was there for the battery. Then it comes with the 156, where you have to make your vehicle battery more better. You have to take the consideration, the cutoff temperature. You have to ensure all the safety check. The AIS which I'm talking currently, just write down all the AIS. You can get these automotive standards AIS very easily on Google Internet, and from there you can check better for your knowledge, and you can see what kind of changes the government has made. So it's a AIS 156 for the batteries currently, and earlier it was 048. You just go with that. And for the retrofitting, it's a AIS 123. So these are the AIS which you have to follow for your any vehicle. Like
AIS 123, which part, sir?
Part 2. So these are the standard which you have to go with, because this is some kind of a, I can say, the procedure. Like if you have to make a biryani, so the procedure is you get this kind of rice, this is a jeera, this is ilachi. So you just mix all the things in the starting. You said my biryani will, I will get the Hyderabadi biryani. So that is not the way you have to go with. So this is the similar way for the automotive standards which you have to follow. What kind of wire, what kind of sockets, what kind of switches, the battery, the motor, what kind of test I have to go with. These AIS clearly mention all these parts. So the cost benefit analysis, definitely we have to, I will talk about this in the next slide also, what kind of things we have to go for, because we are talking about a tech, but we're not talking about the money, because whole science, you can be a good engineer, you can be a good designer, but if your product is not hitting the roads, if it is not available on the road, if people are not liking it, then it's a total failure. Either you have make a rocket. So let's now take the motor selection part. How we have to go with the, what kind of motor. Many people think about what kind of motor we have to choose, because I told you that there are a lot of options in the market. There are, I can say, the PMSM, PLDC, induction. So if you go with the earlier in the starting, we find that induction motor everybody use. Why? The tech is mature. And look, just remember this thing, always go with the mature thing for your full-fledged product. If somebody is doing R&D, somebody is saying, I am making this motor, even that motor is, available in the market, and he is saying that I am making this motor. Don't take it. Either you will have not tested, either the person is not available in the market, either his service support, either his, product quality and life cycle is good. Never go for that. So in the starting, even currently, many people go with the induction motor because the performance, it is a rugged motor. There are no magnets inside, and it is something which people want because it is a mature tech basically. But then we talk about the PMSM, in which the magnets are there. And the difference between the induction and PMSM, if I talk about in the terms of EVs, for the PMSM, why we choose the PMSM? First is that it is having a better torque. PMSM motors are having a better torque than the induction. Another is that it is having a better efficiency. So efficiency means it is 90 to 93% efficient, and induction is 85, 88. So in the electrical, 1% efficiency makes a big difference. And the another part is that the efficiency I talk about, the torque I talk about, the controllability. PMSM motor we can control very easily. For the induction, it is difficult. And the twist here is that the controller for the PMSM is cheaper, and the controller for the induction is costlier. If we go with the example, if induction motor like a 15 kilowatt of motor cost 50,000 rupees, and the 15 kilowatt of PMSM motor cost 80,000 rupees, and the controller for the induction motor cost 1 lakh rupees, and the controller cost for the PMSM cost only 25,000, 35, 40 maximum. So this is something which is in the price side, but yes, PMSM is having a better torque, better efficiency, and better we can control that. But the only demerit in the PMSM is that it used the magnets, in which makes a one more, I can say, a warning here, is that when I talk about that, when we visited the place, we find that the control motor temperature is 100 degrees Celsius. When the magnet goes above the 100 degrees Celsius, your magnet will get demagnetized, which means the power is totally dropped. So for that, we have to go with the cooling part. So I have to make my whole vehicles ventilated. We have to add the cooling so that our temperature range is within that radar, where we can control, where we can make our shell life better, and where we can take a better efficiency and performance from the motor. So for 100 degrees Celsius in the PMSM motor, the motors the magnets are okay, but after that it is something which the heat will demagnetize a magnet. And in the induction, there are no magnet, then there is no worry for that. So this is the big difference currently. But everybody, and even the PMSM is more smooth and very soundless. And this is something which I talk about from my experience, and this is something which I talk about in the technical term. And now let's take an example. If we have to go with the Honda City, so Honda City, for that I have to go with the first weight. What is the weight? Okay, it is the 1000 kg. I'm just taking an example. It's a 1000 kg unladen weight, which means there are no people inside the vehicle. So that is unladen. And GVW means gross vehicle weight, in which we kept the 5% and we just calculate the weight. But basically, it is given by the company by their side. So we have to first go with, when we talk about the motor, how to choose a motor, we have to go with basically the factor weight, then the desired acceleration. Because I told you that, okay, I want the acceleration of I started my career from a college project where I made a first electric car. It was where I kept the electric rickshaw motor back in 2019. But believe me, the acceleration was too bad. Like it was just slowly to start running, but the top speed goes to 60 km/h, but acceleration was not good. So the desired acceleration. And the good part about the EVs are that the acceleration is better than the IC. So you have seen a lot of videos where the Tesla truck is beating the Porsche, and a lot of better EVs are coming with the better acceleration. So the acceleration in the EVs are really good, rather than the petrol diesel car. So you have to go with the desired acceleration. So 0 to 100 or 0 to 60, basically we talk about, I need it in 8 seconds. So that you have in your mind. Then where my vehicle will use, okay, it is driving, we have to, like, this vehicle will go in city, this will go in highway, this will go at Ladakh. But this doesn't make a sense, because if you are making electric vehicle, if you are making a vehicle in India, then you have to make in such a way that if a person is using it in Kanyakumari, if a person is using it in Andhra, he's using it in Ladakh, it has to be compatible with all the states, all the region, and all the tariffs. So that is something you have to clear with your mind. Then we have to calculate the horsepower. There is one case study in the next slides where I have given the formula which I used to how to calculate the motor battery. I'm just giving the literature part here, and we can have a look on the calculation part there. Then the torque characterization. So if I talk about the Honda City or Swift Desire, so the torque is that if you just go with the search in the Google that what are the specifications of the Swift, if I'm talking about Swift or Honda City, so there you find in the spec sheet the torque, maximum torque 110 Newton meter at the rate 2000 RPM. Here EV play a very important role. If we are using a 15 kilowatt of motor with 110 kilowatt of torque, but the acceleration is not at the 2000 RPM, here the EV win, because we can get that torque in the starting RPM. And that's why we have the acceleration really good, and we have very good torque. We have good power starting. For the PMSM, yes, induction is also there, but PMSM wins here. So that is kind of thing, the total horsepower, the total kilowatt, because we are talking about EVs more, we talk about the kilowatts rather than the horsepower. The desired performance which we talk about. Then we talk about the torque characteristics, what kind of torque we are looking for. First of all, we have to remember we are retrofitting a EV, which means we have to make this vehicle better than the petrol car. We are retrofitting a petrol car, we are retrofitting a petrol car or diesel car, and an IC car to EV. So the vehicle was in the, if it is in the petrol, we have to make it in electric with a better power. Like the Swift or the Honda City, we have to make better than the Honda City in the performance range. So that is clear. The torque characteristic, the factors, the towing capacity, all we have to calculate in the starting. And yes, there is one more point. I will just ask this point at the end because I want to know from you in the question answer round. So basically, you know about this part or not. So then the form factors. The form factor basically the engine, the vehicle is designed as per the engine, where we have to place the engine, where we have to place the petrol tank. It is designed basically in that. Now, we are putting a soul into that body. Like it is basically a transplant of heart, kidney, liver in a old body. So we have to just go with that, considering those factors. Okay, this is the engine compartment. We have taken it outside. Here we can use a motor. What are the space we have to go with? And we have to work on the standardization. It is not something which we can work on every vehicle. Standardize the things if you want to go with a scalable. Then the motor form factor, the dimensions, land breadth. Okay, this is space. This is where the ventilation coming. There are a lot of challenges you have if you go with the designing part. Because placing the motor, everything, if you have to go it for a short run, you can do anything. But if you have to make it as a OEM, if you are thinking like a Mercedes, you are thinking like a Hyundai, you are thinking like a Tesla, you have to consider all the factors. Then you have to choose a motor with a good torque, which can handle the flange coupling, the gearbox. You have to consider all the things. What torque it is, the ANSYS, in this ANSYS you have to do the load part, how much of load it can bear, what is the gear ratio I have to go with. So that is something which is a very vast subject, and I'm currently pursuing my master's research from IIT Delhi in this subject also, like in this particular subject, because this is a very big subject. This is something which I can say in this webinar, but this is something the highlight kind of thing which I can talk about. So you have to go with the all characteristics. Then when we talk about the motor type, I told you the motor by induction, by PMSM, but there is also the I can say the efficiency part, because when we are talking about the induction, PMSM and SRM, then we have to go with the efficiency, because our motor should be not like in that manner that, okay, this is consuming a 200 ampere of current in, when we are accelerating it. So that doesn't make a sense. So we have to consider that part also. Although it is good, it is powerful, but it has to consume less, energy. It should be kind of a splendor where we have to just keep the petrol 1 liter and it has to go for 70 kilometers. So that thing you have to also consider. What kind of motor, like, it's a very simple thing. We have to give the money. We have, like, it is something kind of thing I can say, value for the money, but here we can say it's a value for the technology. I can say the technology which you are adding, it has to make the value there, because the good efficiency, good range, good power density, it has to make the whole performance good. Like if you are using 20 kilowatt of pack, 23 kilowatt of pack, it has to run for under 30 kilometer, but it is running only for 80 kilometer, which means your acceleration is really good, but which means it is not, touching the thresh. It is not something which is in the market, which is coming with which is in the market available, although you have made your vehicle very fast. So the vehicle usage and the vehicle where it has to go in the Indian cities, it has to be very clear. So the efficiency and the consumption you have to consider. The motor has to be powerful, but it has not to consume a lot of current. So that kind of thing you have to go with. Now the most expensive part is the battery system, and 80% of the cost is your battery. In our vehicle, I can say if we are selling our vehicle at 10 lakh rupees, 7 lakh rupees is only for the batteries. And batteries are the very important thing. So when we talk about the motor, okay, 15 kilowatt of motor, 20 kilowatt of motor we are using. This is the power efficiency. This is the torque. Okay, this is really good power. Now you have to, okay, you have set the engine, but now the question comes, what kind of fuel you have to provide? Because fuel is the something like you have a V8 engine, V6 engine, but you are putting a kerosene in that, it will never start. And if it is a petrol car, you are giving a diesel fuel, it will never get started. So the fuel is something which is a crucial part in the EV, because what kind of battery you are using. If you are using, let's say, in the Reva, basically in 2013, we are having few Revas in our yard. So I see there the people, that company use lead acid batteries. But if you are using a lead acid battery, though, how you can get a 3C, 2C discharge there? So that thing you have to clear with that. What kind of fuel you are using? And yes, in the market there are only currently the fuel here there is the lithium ion. But in the lithium ion there are a lot of chemistries. So for Tesla, for any company, good company, they are going with the LFP, and same we are using also the LFP, lithium iron phosphate. So in the battery also, it is very big subject, because battery is something which you have to study from a chemistry level, but here you are not doing some, a PhD or any masters. You have to go with the market. So I'm just telling you about what the market, how we have to go with the market selection. So the if we go with the motor, it's at 15 kilowatt. So now the condition for our vehicle is that we have to run this vehicle for 150 kilometers. So when we choose the battery, there are calculations in the next slide, after few slides. So we have to go with what kind of power we have to use. If we are using the LFP or we are using good BMS, we have done the good designing part. Here it comes that when I am pressing my pedal, the 15 kilowatt motor behaves, goes with the peak and gives me 30 kilowatt of power for a few seconds, which means my battery is able to provide a double of its capacity. If it is a 23 kilowatt of battery, it has to give 50 kilowatt of power for few seconds or 30 kilowatt to meet that motor. So the fuel is very important, what kind of fuel you're using. And the designing of the battery is a very important, crucial thing. So in our vehicle, when we press the pedal, 15 kilowatt motor we are using, when we are pressing the pedal, here, logically it has to, it depends on the load. If there is a slope, if there people are inside, so the load on the battery is basically 10 kilowatt, 12 kilowatt, 18 kilowatt, 3 kilowatt. It varies. So in that way we get the range. But in the starting, if I'm giving an acceleration, the load goes up to 27 kilowatt, which means the 400 ampere of current is drawing from my battery, but my battery is only the 300 ampere. So the lithium here plays a very important role because we can have a 2C rate. The C rate is basically, if it is 100 ampere of current, we can if it is 1C or 2C, we can take out a double of its current from its the output. So on that part, we feel if it is a 300 ampere of current, we can draw 600 ampere at a 1 or 2C. So this is something which we have to go with the fuel, with the battery, and then we have to calculate the energy consumption. Because if my vehicle is consuming a lot of current, then there is also no sense, because either my motor is not behaving in a same way what it has to behave, because the architecture, the designing part, but it is not behaving, then it is totally something is missing, because either it's from the battery side or either it's from the motor side. And then you have to consider the efficiency losses also, because you have to just, it's a logical and it's a very technical thing. You have to keep in mind that every battery, lithium battery, it has the 20% of the DOD, which means if I say, sir, this is a 10 kilowatt of battery, in actual it is only 8 kilowatt of battery, because the 20% of the DOD is there. The 20% DOD, it is basically the graph from 3.2 to 2.5. When we go down, when we degrade, when we discharge the cell, in the 2.7, it drops suddenly, like in that chart. It's basically behavior of the lithium cell, the lithium chemistry basically. It is not stable at the end point. So we take a 20% DOD always. So whatever you are having, if somebody is saying that this is 3 kilowatt of pack, calculate the 20% DOD there. It is not the same 20% you are getting there. It is the DOD we have to calculate, the deep discharge basically. So when you calculate the battery capacity, you have to add the safety margin also. Now here is the one question also, one tricky thing also. If let's take example, my battery needs, my vehicle needs for 100 kilometer range, it needs 10 kilowatt of battery. Okay, I calculated, from my mathematical calculation, I said I need 10 kilowatt of motor, but I will never use the 10 kilowatt of battery. Sorry, 10 kilowatt battery. I will never use the 10 kilowatt of battery. Why? I use a 12 kilowatt of battery, because I have to take a margin of 20%. Because my calculation says that it is 10 kilowatt, but there is DOD also in the lithium cell, lithium packs. So 20% I'm taking a margin to meet that thing. So in all the battery which you see in the Tigor, Verito, anywhere, if they say 23 kilowatt of battery, always calculate the 20% DOD there. And after that, and then again AIS 156, the AIS 58, you have to go with, you have to see what are the safety precautions, what are the measures which government has mentioned in the automotive standard. We have to follow that. We have to choose a very particular BMS, because BMS is the most sensitive thing in the battery, because if you are choosing a wrong BMS, your battery will get fired easily, you will not get a proper output. So the BMS is very important. The designing of the battery is very important, and that is something which you has to consider in your mind. Here is the one example, like if the vehicle consumption is 250 watt-hour per miles, and the desired range we need is the 200 miles, and the efficiency loss is 15%. And sorry, I forgot one more point here, is that when you are calculating 20% DOD, but there is the losses also in your vehicle. in the retrofitted vehicle or even the new vehicle. The tire losses, the rolling resistance, the aerodynamic loss, you have to consider that part also. So if it is 12 kilowatt, you have to add a margin of 1 kilowatt also for that to meet up that all losses. So these are the losses you have to calculate. So here the total energy consumption is the vehicle energy consumption multiplied desired range, which is a 50,000 watt hour, which we have to require for a 200 miles. This is a very basic calculation we have to go. And if somebody wants to take the picture of this, you can take, because this is a very good formula you can use. And then we have to go with the adjusted energy consumption, which I mentioned that 50% of the efficiency loss we need. And here you can see the total energy consumption multiplied by 1 plus efficiency losses. You can get this formula very easily on the Google. These are not some rocket science, a very basic thing. So then required battery. Look, this is something 57,000. It's a 57 kilowatt battery which we required. But I mentioned that we have to keep up the battery, DOD, the efficiency also there, the efficiency factor and all the things we have to calculate. So when we divide the adjusted energy consumption by battery efficiency factor, which is 0.85, we will get the desired battery. Now you can see from 50,000, like 50 kilowatt to 67 kilowatt, which means the 17 kilowatt is added. So this kind of adjustment you have to do. It is not something 10 kilowatt you have to use kilowatt. No, it's not 3 kilowatt. No, it's like दिखता कुछ है बिकता कुछ है. So the better example is that हाथी के दांत दिखाने के कुछ और खाने के कुछ. So we are talking about 10 kilowatt, but it is not a 10 kilowatt. It is basically 13 kilowatt, in which we have calculated the DOD, we have calculated the losses, we have calculated the efficiency. All of the battery factor we have calculated. This is the range we have to, battery capacity we have to go with. This is our one battery design which we have done for the Gypsy. So this is we have done by ourselves the battery design. Here you can see the cells. We are using the here the 160. It is the cell dimension. Like this is cell which you get from the vendor. He gives you the cell basically data sheet in which the cell dias everything is here. So we are using the prismatic cell in this. We are not using NMC. Tesla is using the cylindrical cell 18650. We are using the prismatic 100 AS cell. So this is a if this length is very large, it makes a trouble for you in the battery fitment. So your whole brain is total stuck with this part. How I can design the battery, where I can keep the battery. And believe me, without the experience, you can't do this thing, because this is something which you get with the experience. The battery BMS placement, the type of connector which you are using, the type of wire you are using, all these things you have to consider, and you can make the battery by your own. You can design it. And there are a lot of people, engineers who design the battery. Then in this pack, we are using the 69 cells. And 69 cells are connected in it's connected in series, and it's a 25S, and we are having 72 volt 300 Ah of capacity, and it's 23 kilowatt of battery, but it is not actually 33. We are only getting 18 kilowatt of power. So one more case here, and one of my worst experience, which cost me 25 lakh rupees of I can say loss. When we are using the army project, there I calculated all the battery calculations. Okay, this is the battery calculation we need. This is something 18 kilowatt, 16 to 18 kilowatt. For client requirement was 120 kilometer with full load and with the full speed. So that is a achievable range. It is a practical range which I am talking about. And in the AR and ICAD, your range will be 200 kilometer. So even if it is you are buying any two-wheeler, three-wheeler, they always mention 200 kilometer range. There is STAR and ARI, ICAT, they have mentioned. So that is the lab report. In the actual, it is 110, 130. So I'm talking about the actual range. I'm not talking about any claimed or lab range. So when I was doing the calculation here, then I calculated, okay, we need like 18 kilowatt of power. We use the 80 volt 200 Ah of battery. And when we start, taking a trial on that batteries, we get 95 maximum of 204 kilometers of range. Actually, if you are driving very good, like a very systematic manner, the range was 104, maximum. And I was not getting how it is running. We have done lot of, test. We wait. We done 30 cycles so that cell will get balanced. It will give the backup, but the results are not getting. At the end, I doing a lot of brainstorming and rectifying the error, why it is not giving us a range, what the client desired range. Then I rechecked my calculation. I found that I have not calculated 20% DOD and the efficiency losses. I forgot that part, and that cost me 25 lakh rupees of penalty, because I have already quoted some price to the army, and then I have to go with a bigger pack. So actually it was not 16-18 kilowatt of pack. It was basically 15 to 14 kilowatt of pack, which was in the back, which was actually working. So now the 23 kilowatt of pack which we are giving, it is behaving as a 18. So this is very big thing which you have to keep in mind, because these basic small things cost very big for you. So charging infrastructure. So we talk about the motor, we talk about the batteries. Now we talk about the charging, and this is the subject which you know very better. The home charger is there, the DC charger are there. Home charger is something which you can charge your vehicle from home with 220 volt. It goes maximum up to 3 kilowatt, because our meter is having only 3 kilowatt of 3.2 kilowatt of capacity. So that is the home charger which you have to give. We provide the home charger with our vehicles, where they can charge their vehicles easily from their home switch. And another is the fast public charger. There you have the charger from 19 kilowatt, 15 kilowatt easily. And you charge your vehicle from the fast charger. And fast charging is not recommended even by the OEMs, because when you do the fast charging, the cell get heated, and heat makes the chemistry of the lithium very, I can say, it decreases the life of the cell basically in a short way. So the fast charger is not recommended unless and until you are in a for a tour or not in the city. So avoid that. So public fast charger, DC fast charger, there are a lot of protocols which you have to follow. The CCS type 2, which are the European, Chinese, which is in the market. So these are the few pictures of the home charger and the fast chargers which we provide. And also there is one more formula which you have to go with. Everybody note this thing. It's a very basic formula. Like if my battery is 10 kilowatt, and a company has given me 2 kilowatt of charger, so I have to charge it home charger basically. So if somebody say how much time it will take, just divide 10 by 2. It's a 5, which means 5 hours it will get full charge. It's a very basic formula. Everybody calculate. It is a better for your information. And the other is that if I'm getting if I have to charge my battery from public charger, the charger is 5 kilowatt. So how much time my scooty or my 3-wheeler will take, the vehicle will take? So 5 is 10 divided by 5. It's a 2. In 2 hours, my vehicle will get charged. So very basic formula. Now the important thing is that cost analysis. You have done a lot of R&D. You have done a lot of brainstorming. You have made the vehicle. If you are in a company, if you are in a good company, you have done a lot of even either it's your own startup, you have done a lot of things. But the part is that cost analysis. Let's take an example. You have made a vehicle and that cost 15-20 lakh rupees. Why not buy a Tata Nexon or any new vehicle? Why have to convert my old vehicle to electric? So that is a big challenge for this industry. Customer is a very price sensitive. He will not spend because he is having a lot of option in the market what you are costing him. So if for the Gypsy, I'm taking example, like for me, they told me how much Gypsy cost. It cost 8 lakh almost. What are the specs you are giving? We are giving a specs which is similar to the Tata Tigor. So how much Tata Tigor cost? It costs around 14 lakh rupees. And how much your vehicle cost? So if let's take example, if it cost, or not example, it cost around 7 lakh rupees. So okay, like it is the half of the price you are giving. Okay, good. But now if I have to give this cost analysis to my customer, this is the gypsy basic. Like I have to, tell him, understand him, what are the benefits you will get to when you make your car to electric. The mileage, this is basically for the Maruti Eco. One of my client is asking for that, so I have made for that. It's not for the Gypsy. So for the Maruti Eco, it's 18 kilometer per liter mileage you will get. It is what company says. So cost for running 100 kilometers is 538 rupees. I'm just talking about 100 kilometer. Carbon emission is 2.6 gram per kilometer. So you can just calculate it. For 100 kilometer, it's 2.8 kg. For 1,000 kilometer, for 1 lakh kilometer, it will be in the ton. So you are saving carbon. And now there are carbon trading in India. You can sell the carbon credits. You have to register for that. That is another process. You can also search it on Google and we get a better data. So maintenance cost for 100 kilometers is 30 rupees. It's like a 20 rupees. So fuel consumption, if I talk about 100 kilometer every day for 1 month, it's a 166 liter. So cost for petrol for 1 month, 100 kilometer per day. If I running 100 kilometer per day, and how much fuel cost for 166 liter? It is 1,61,660 rupees. And the carbon emission for 1 month is 8.4 kg. And similar, if I go with the 1 year, we are spending, I think there is some error in the 1 month calculation. It's I think 16,000. And for the 1 year, it is 1,93,000. So it's a 16,000 basically. There's some error. And carbon emission in 1 year, we have said 100 kg. So this is something, person is spending for 100 kilometer every day, 365 days, spending 1,90,000, almost 2 lakh rupees for 100 kilometer every day in Maruti Eco, and he's emitting 100 kg of carbon. So if we convert it to electric, so if I'm using their 12 kilowatt of pack for 100 kilometer or 14 kilowatt, so taking 7 rupees unit electricity unit, so it cost 126 to 150. Carbon emission is 0. Maintenance cost is 5 because it is having very less maintenance. Electric consumption is 540 units per month for 100 kilometer, and for the electricity cost, there it is spending 16,000 rupees. Here he has to spend only 3,700 rupees. Carbon emission for 1 month is 0. The electric consumption for 1 year is 6,480, and just look at this number, 1,93,224 for 1 year, 45,360 for 1 year. So this is the difference you have to tell the customer. So this is your saving. If you spend a 6 lakh rupees in your conversion car, you can recover your money within 2-3 years. And 8 years of the life is for the battery. So this is the big difference you have to go with. So now the end part of our today's session is a case study. So this is Ace Electric Crane, where we are the technical partner for this. And the challenge for that, this is basically, it's a F-150 action construction equipment. You can see this in the website. So it's basically in the petrol version. So we got opportunity to, I got opportunity to meet with the owner of the company, who said that we are working on this, and if you can work on this for the consultation, being a technical partner. So we start working on this crane. So here in this crane, it is basically a diesel crane. So they said that what you are doing, replace it in here, but with a big scale. So basically this crane is retrofitted, but it's a OEM product. Like it is similar way. I told you in the starting that new vehicle, old vehicle, new EV, retrofit EV, it's the same. Only chassis makes a difference. So we went to factory where these cranes they manufacture it's in the Faridabad, Palwal. So they pull out the engine, diesel engine. They said, now you make it electric. Tell us how we can make, and their team, and it took 1 year for us to brainstorm. The challenge for this crane was the powertrain, battery, load capacity, duty cycle, gradability, compliance, charging cycle. Powertrain, first of all, big issue because it's a 4x4. Second, battery, because it is not something, 10, 20 kilowatt you required. Load capacity is 30 ton. This whole crane is, 15 ton and it lifts 15 ton. The, customer requirement is very clear. 15 ton, it will, lift. Total capacity is 30 ton. Duty cycle. What is duty cycle? In the construction vehicles, their mileage is not something we require. We count, their duty cycle is count. Okay, it counts for 12, 13 hours of duty cycle. Gradability, because it will not, it is not something which will run on a highway. It has to go with the off-road, it has to go in a very different terrain. So gradability there. Compliance, because whatever you are making, it has to comply with the government rules and government norms. And then charging cycle. So this is something a very similar way the electricity is explained, how it works. So if your wire is less, this is volt, this is ohm. So I can say in this picture, you can understand the whole electricity, how it works and what does the electricity means. So for this thing, I have to calculate what are the motor. I mentioned in the earlier slide, we said, first of all, assessment, we know, then power motor calculation, then battery calculation, then compliance. We go with this calculation. You can see it's a handwritten. Sorry for the, my handwriting is not that good. So the crane was basically, it's a lifting capacity. The client requirement is 15 ton. Operating weight is 15,525 kg, which is 15 ton. Transmission synchro mesh. Top speed 40 km. Gradability is 40% unladen. So it is very clear that this is the same petrol. It is basically on a diesel engine, not petrol. They want a replicate in the electric. I told you the best way to make the car electric is that to replicate the petrol diesel car with this electric power, with our electric power. So best way, because the person is driving already that vehicle in the petrol. Obviously, it will get better if you use the electric, but first your vision is that to replicate that. They want the same gearbox because they said you have to just replace what your architecture here also. So we use the first hill climb for this is the mass into gravity into sine theta. Mass we are having 15,525, gravity 9.8. Sine theta we get from the gradability. If you convert the 40% gravity into the angle, so you will get the value of 0.366. You will get on the Google easily. So this is the force we get. It's a 55761.29 Newton. So these are the formula which I have basically made. It is something which works for me always. And yes, it is a basic formula also, but this is something tricky formula. I can say that some kind of I can say most quick way to understand this. So the total power is that total force into speed. For the speed, we have to take it in the meter per second. So 40 kilometer was the requirement. We have to divide it with the 5 by 18. It's on the Google as well to convert it to meter per second. It's 11.11. So force was 556,761 Newton multiplied by speed 11.11. You get the 77 kilowatt of power. This is the power you have to require for your motor, for your crane to run. This is the very simple, easy formula I have developed from where you get the power rating of the vehicle. But for that, all this data has to be very clear. But these formula vary because I'm talking about the one case study of my crane. Here the things are different, but you can implement in other also. So
But what is operating weight, sir?
Operating weight is 15,525. It's a 15 ton basically. So total weight GVW is 30 ton, 30,000 kg.
What do you mean by operating weight?
The lifting weight. This
Yes.
bomb.
Okay, fine.
Yes, this is the bomb. which it has to lift. So 15 ton is the whole vehicle weight, and 15 it lifts. So when we calculate all this thing, we get the 77 kilowatt of power rating. It is the desirable rating which we have to go. It is the maximum, because we have taken 40 kilometer per hour speed. So, but now the things come here that 77 kilowatt of the power you required. No, we don't need 77 kilowatt of power. It is the 77 kilowatt of peak power we required. And this is something which we have taken plus, because 40 kilometers is not something which a vehicle will continue to run. Because I am taking 15 ton of load with the 40 kilometer of speed it is running, which is not practically possible. It can never run on that. But in the calculation, we take the worst of the worst. As I mentioned, it cost me already 25 lakh rupees in the earlier. So this is 77 kilowatt of power which is required, and for that this is the peak, and we are having in the India with the one company inventor we develop the actual half of the motor, that is 37 kilowatt of motor with the peak power of around 75 kilowatt, and the torque is the same what that engine is having, because we are having a spec sheet. So it is
hello.
Yes.
Sir, what do you mean by unladen? Like you have mentioned in the gradability section.
Unladen is, this currently is the unladen weight.
Okay.
In which there is no load, no driver sitting inside.
Okay, curb weight in short.
Yes, unladen curb weight.
Okay.
And gross vehicle weight is that when it is with the full load, it is the driver is inside, right?
Okay.
So when we get this power rating, is a half of the power rating which we get. Now we get clear with the power, and definitely it is a PMSO motor because the requirement is very clear. And for this, here we have to go with the voltage. What kind of voltage we have to use? So we use the 384 volt here because the motor is big, the power requirement is big. The better the power, the better the voltage. Higher the voltage, lower the current, the I square or losses will be very less, which means heating of the wire, heating of the batteries will not be there. So we go with the high voltage system. To calculate with the battery, what kind of battery we have to use? Because I am taking 40 kilometer per hour. I'm here. What I do, the twist is that I calculate this thing as 100 kilometer. But for this particular thing, it is a duty cycle. But I am taking it as 100 kilometer. It has to run. So basically, for a vehicle we go with that part, but it synced in the, I can say how it synced. So for reference lab test, it is my formula to go with the 1 kilowatt. We use 1 ton. So 1 kilowatt of the motor, it is we calculate the one kilowatt, 1000 kg. It's a very simple example. You can get it from the e-rickshaw. So lab reference we have there from there. If you go with the e-rickshaw, there are 750 kilowatt of motor, there is 1200 watt of motor, and the load, the 8-9 people are sitting there. So almost we take it as a 1 ton for 1 kilowatt, and the energy consumption in the the reference we take a 70 watt hour per kilometer for 1 ton. So for the 1 ton with the 40 kilometer speed, it should be almost 70 to 80. It varies, but this is something which you take as a reference. And it also depends on the vehicle dynamics and lot of other factors also. But to ensure with the battery capacity, whatever I'm talking about here in the calculation part, there is always a difference in the practical parts. When you go with the practical, when you make the vehicle, when you do all the things, there is always an error of margin. But this gives us a better reference how we have to go with that calculations. So if I talking about the weight 15 ton, gross weight 30 ton, I have written the 23. Just wait. It's 30 ton. It's a 23 ton basically. It's not a 30, I guess. So here this is so it's a 15 weight 15 ton, and the lifting capacity is not 15 ton. It's something I think around 11 ton. So that makes 23 ton. So if you take it to 30 also, so you have to multiply 70 into 30, because I mentioned here that we take 70 watt-hour per 1 ton. So it's basically 70 watt-hour you have to multiply with the 23, either we take it 30, but for the 40 kilometer per hour. So we are just taking currently, assuming it is not any kind of crane, we are just assuming it as a vehicle, electric vehicle. So for that we are doing calculation. So for 100 kilometer running at 40 kilometer, we have to just multiply the value which we get it from here to the kilometer. There we get the kilowatt hour of the battery consumption, and taking 20% DOD in that, it is a 193 kilowatt. It's not km, it's a kilowatt hour, which required the battery for running this vehicle for 3 hours with the 40 kilometer speed to 100 kilometer. But that is not something in the crane, because here we need the duty cycle. So what does basically this means? And the battery which we use in this vehicle is the same. It's a 150 kilowatt hour battery which we used. So the calculation, this formula which I mentioned here, it was almost the same, because I have taken a lot of margin of error here. I have taken the 43 kilowatt hour more, because there are a lot of things which it is basically a rough formula which we are using, but there are better. It depends on the type of gear, type of wheelbase. Lot of things are inside which you have to go with the very at every single step you have to calculate. But these are some kind of check your the assumption, they check your motor, what kind of motor you're using. So this is the photo when we start working on it. This is during the launch. Is the owner of the company. So when it was launched, but there are a lot of challenges in this crane. So in this crane, when we made this crane, this is the motor was accurate, the power rating was accurate, which we made. The battery was also there. Now, if you know that in this crane there is 5 ton of weight which is installed here. It is in the form of iron dust and also iron part here in the petrol one. Here you can see this is the petrol one. Sorry, diesel one. I'm again saying here it is engine which we have removed. So in this vehicle, here the company uses the 5 ton of the iron dust and iron, the load basically, to ensure that when it lifts the 15 ton of weight, or 10, sorry, it's not 15, it's 10, 11 ton of weight, it will get balanced. Otherwise, what happens that if it lifts the weight, there is no weight here, it will get down from this side. So they always keep the weight here. In this battery, what now we have the issue here that the cost analysis. Now we calculate that, okay, if we are using 150 kilowatt hour of battery in this crane, it costs only 25 to 30 lakh rupees for the battery. So how it can be achievable? Because this crane which is available in the market with 18-20 lakh rupees, it costs 40 lakh rupees, and there is no sense to buy this motor crane. Then we keep brainstorm, and we come to conclusion that we will use the lead acid batteries here. We use the Exide batteries, which is giving the same power but not a normal batteries, lead acid battery with a good grade. So the batteries, for the graphene batteries, what the issue is that they are very bulky, they are having very big weight. Lithium is not having that weight. So that weight, blessing in the disguise basically, that weight we use as a counterweight here. So it provides the power, but it also provides the counter. Otherwise, we have to use a 5 ton of iron to ensure the management of weight balancing of the crane. So that battery gives us the counterweight also, and make the price half of the from the lithium. So this is the thing which we have. Then this, I don't know what is the cost of this, but that makes a very big difference in this whole crane. And here also we see the challenges such as that the vehicle is not running at 30 kilometer per hour speed, like basically 40 I'm talking about, but it is 25 kilometer per hour which they permit to this crane. And we see that there is heating issue again and again. Then we work on the compressor side to ensure is all hydraulic system, because all the things are running from the engine, we couple it with the motor. And most amazing thing, what an innovative thing we develop in this crane is that only a single motor is running the vehicle, running this boom also. So here is the one compressor which hydraulic, or not compressor, hydraulic, which run this crane boom. So one single motor is doing all this thing. So this is the innovation, this is the tech which is developed in the total in India, and this is how we have to solve the problem. So this was the one case study which we work on, and this is successfully launched by Shri Nitin Gadkari ji last year. And this is something product which we are very proud of, and we have learned a lot of things from this. We are implementing something bigger in the future also, but from oldest vintage car which we have done is 1916, that we make to electric, and that is running very smoothly and fine today also. And the another biggest 30,000, 400 kg was that vehicle weight, and this is a 30,000 kg. We started from that, and we are continuously going, but this is something the achievable we have got. So the approach is very clear. You have to just go with the assessment, you have to go with the planning, the power rating, the particular motor, the particular the choice of the frame, and you have to just go with logical what we have to exactly client need from us. Otherwise, what happens is that we become the Elon Musk, we become the some kind of scientist. We start saying, okay, we can do this, we can do that. No, see what a client need, see how much this vehicle can go up to, see how kind of things we can use, the cost benefits, the cost analysis to the user, and how we can this thing scalable. This is not, and we are having in the retrofitment, there is 18% tax. For the new EV, there is only 5% tax. So one challenge is there. And for the retrofitment, people see this industry as a purani gaadiyan hai, it's a scrap kind of market, but no, it's a $70 billion of market. It's a very big market, but only challenge is that we are not working very clearly. But we are getting results. But yes, if the people come with these solutions, with this approach, they can definitely help. So if you want to connect with me, you can just scan the code. It's a LinkedIn code. You can connect with here. And I'll close my screen and come to the question answer round. So scan this. If you want to connect, I am closing my screen and coming to the screen round. Hello.
Yeah, sir. Sir, can I get your mail ID or number?
I can't provide you my number, but I can definitely give you a reply on LinkedIn. So if you are having the link here, you can scan this code. I will get here.
Actually,
you are not able to scan it. Just search I will just write in here my name. I will share you my email in the chat box. So I hope this session is very helpful, because this subject is not something which I can tell you in a 1 hour or 2 hour. It took me around 3 to 4 years to just learn, I can say 10% of about the EVs, but it's a very big subject, it's a very vast subject, and everybody has to study by their own. I can just give you the highlights what this engineering is, and let's
sorry to interrupt.
Yeah, please.
I have a question here.
Yeah, sure, please.
So I can see that there are multiple things involved when you decide something, say a retrofit to be done to a vehicle, a two-wheeler or a four-wheeler. So from a student point of view, so who's planning to do something on a retrofitting, what would you suggest? It's like a more of a basic, where I would see this calculation part. Once you understand the requirement from the customer, and you're going to see what is the ROI on, say, converting this retrofit. So later that part, there are multiple technologies, multiple people involved, like your mechanical, your electrical, electronics, programming, simulation part. So how exactly you're going to handle all these, like multiple teams? There I'm not able to understand. Like if a student would like to get into a retrofit, where exactly he can focus?
Look, Abdullah, the thing is that retrofitment is not something which is, a student for a student. It's basically EV. It is only, I want to work in a car company. Okay, which car company you want to work? I want to work on a, in a Hyundai or in a Maruti. It is the same. Retrofitment is basically an electric vehicle. You are not making something, totally different thing. It is the same EV, same only chasis there. So for a student, if you want to go into the EV industry for a retrofitment, I will suggest, if you want to make your own startup, I will suggest don't do. This is a very challenging industry. Don't do. Either you don't have a lot of money in your pocket, and no investor will give you the money.
Right.
I'm
Hi, Jubair.
Yes.
Sorry for the interruption. I just wanted to let you know that session is really nice. I mean, I'm glad to see that even after 2 hours, the students are so interested and they are taking the interest in your session. So it was just a compliment. I thought that if I'm here, because I'm not from the technical background, I'm the HR, but still even I was thinking, what are these things? And even I was enjoying that. So it's a really nice, I hope the students are also enjoying the session.
Yeah, I hope everybody. I'm not good in explaining, but I try my best.
No,
because,
it was really lovely session, and I just came to check, and I was like, yo, students are still here and they are participating even.
No, definitely. I think it is something which makes everybody more, relatable. Coming back to Abdullah, to your question, getting back to, EV in any company, either 2-wheeler, 3-wheeler, the architecture is always same. I will just, just give me, I will share you later if you connect me on the mail. So basically, it is something, not for the startup. Look, yes.
Sir, one question. Plus speak in Hindi. My English so weak. मैं आपसे ये पूछना चाहता हूँ कि जैसे हम ऑलरेडी, मैं दिल्ली से हूँ. ऑलरेडी यहाँ पे काफी इलेक्ट्रिक स्कूटर है, जैसे लाइक ओला, एथर. मैं पर्टिकुलर 2-व्हीलर पर फोकस करना चाहता हूँ, ना कि रेट्रोफिटिंग. आने वाले टाइम पे वही स्कूटर को ठीक करना पड़ेगा. मार्केट में चल रहे हैं, जो बड़ी बड़ी कंपनी आएंगी वो छोटे छोटे बंदों को खा जाएंगी. और मैं किसी को बोलूं 10 लाख लगा के गाड़ी बना ले, तो कोई नहीं बनाएगा, रिस्क नहीं लेगा 10 लाख का. आपको पता है. तो मैं ये चाहता हूँ कि 2-व्हीलर पे हम सर फोकस कर सकते. ओला पे जैसे वो कभी खराब होती है, हमारे पास आए तो हम ठीक कर पाए. उसमें क्या है कि सॉफ्टवेयर है, टेक्निकल है, उसके बारे में चाहता हूँ सर. 2-व्हीलर में फोकस करना चाहता हूँ.
आपका नाम क्या है?
मेरा नाम बलविंदर है.
आपका ड्रीम ईवी लिख के बलविंदर जी, देखिए मैं आपको ना एक बड़ी कड़वी बात बताऊंगा. अगर मेरी बाइक है, मेरा कस्टमर आपके पास क्यों सर्विस के लिए आए? मैं उसको 5 साल की वारंटी दे रहा हूँ, और अगर एक तार भी खुली मैं वारंटी हटा दूंगा. आप खेल समझ रहे हैं?
सर मैं एग्री हूँ, पर ओला मैं समझ गया.
मैं आ रहा हूँ उसी पॉइंट पे आ रहा हूँ. ओला में क्या कर रहे हैं?
ऑलरेडी सर सर्विस नहीं मिल पा रही.
नहीं, वही मैं कह रहा हूँ. देखिए इसमें बलविंदर जी,
ओला के केस में क्या होता है कि साइड स्टैंड भी हम एक्स्ट्रा लगा देते हैं, तो वारंटी एक्स्ट्रा मानते हैं वो.
मैं एग्जैक्टली राहुल जी, मैं उसी बात पे आ रहा हूँ, और बलविंदर जी मैं उसी बात पे आ रहा हूँ कि देखिए कड़वी बात यहाँ पे ये है कि मैं भी अपनी जो गाड़ियां हमारी कंपनी की जाती हैं टैडपोल की, हमारी एक नट बेगर खुल जाए ना, मैं कस्टमर की 5 साल की वारंटी खत्म कर देता हूँ. और उससे क्या होता है कि कस्टमर डर जाता है. इवन देखिए हमारे घर के अंदर टीवी है ना, तो मैं 40 किलोमीटर दूर जाके सर्विस सेंटर के अंदर टीवी को रिपेयर करवाऊंगा, मैं नॉर्मल मैकेनिक से नहीं करवाऊंगा. तो इस इंडस्ट्री के अंदर दिक्कत सबसे बड़ी क्या है कि सारे व्हीकल जो है वारंटी के अंदर है, और इसके अंदर हमें पता नहीं कि इसके अंदर एग्जैक्टली क्या है, क्योंकि हर एक का टैग अलग है. देखिए आर्किटेक्चर सेम है, मोटर पता है इसके अंदर क्या है, लेकिन मोटर का कैन, उसका पावर, उसका सिग्नल लेना वो सेम नहीं, और ये कोई भी नहीं बताना चाहता कि हम इसको कैसे बना रहे हैं. अब देखिए जो अगर पेट्रोल की बात करें, 100 साल पुरानी टेक्नोलॉजी, हर एक को पता है कैसे खोलना है. लेकिन अगर हम पर्टिकुलर BMW ऐसी गाड़ियों की बात करें, आपको बहुत ही कम मैकेनिक मिलेंगे जो उस गाड़ी के ऊपर काम करते हैं. तो सेम ईवी इंडस्ट्री भी करंटली है. अगर आपको बाइक बनानी है, आप कहते हैं कि मैं अगर खुद की बाइक बनाता हूँ, 10 लाख रुपए कोई इन्वेस्ट करेगा. देखिए वरिंदर जी, गाड़ी आप बना लेंगे, बाइक आप बना लेंगे, 10 लाख तो बहुत ज्यादा अमाउंट है. 5 लाख में बना देंगे, 3 लाख में बना देंगे. आपको पता होना चाहिए कि एक बाइक को अगर आपको आईकैट या एआरआई कराना है तो उसकी फीस 2 करोड़ रुपए है उसको पास कराने की, और इन्वेस्टर से 2 करोड़ रुपए लेके पास कराना, कोई इन्वेस्टर आपको 2 करोड़ रुपए पासिंग के नहीं देगा। 25 किलोमीटर के नीचे अगर आप चलाते हैं उस पर आपको कोई कंप्लायंस की जरूरत नहीं है। तो वो इंडस्ट्री आपके लिए बहुत ओपन है। अगर आप दिल्ली के अंदर है तो आपने बाज बाइक सुना होगा, आईआईटी दिल्ली का स्टार्टअप है, उन्होंने 25 डिलीवरी के लिए 25 किलोमीटर पर आवर के नीचे की बाइक्स बनाई हैं जो कि डिलीवरी में यूज होती है, यूलू टाइप की। तो वो इंडस्ट्री बहुत ही अच्छी जिसमें आप बहुत ही अच्छा बना सकते हैं, और उसकी जो मोटर आर्किटेक्चर बहुत ही सिंपल है। तो वो इंडस्ट्री बहुत अच्छी है।
ठीक है सर, ठीक है।
हाँ सर, मेरा क्वेश्चन अभी बाकी है।
हाँ अब्दुल्ला, सॉरी आपका क्वेश्चन बाकी है, मैं आपका क्वेश्चन थोड़ा रिपीट करेंगे आप?
हाँ वही जो रेट्रोफिटिंग इन
हाँ,
केस
मैं रेट्रोफिटिंग का वही कह रहा। देखिए रेट्रोफिटिंग ईवी इज सेम इंडस्ट्री है, तो बस नाम है। अभी तो ईवीफिकेशन भी मैंने कल ही नई टर्म सुनी इसके लिए। तो इसके अंदर आपके किसी भी कंपनी के अंदर आप जाके, बहुत सारी कंपनीज हैं जो कि ईवी पे काम कर रही हैं, 3 व्हीलर बना रहे हैं, 2 व्हीलर बना रहे हैं, आर्किटेक्चर इज सेम। यू कैन वर्क ऑन दैट बीइंग एज अ स्टूडेंट। अगर आप कहते हैं कि मैं इफ आई हैव टू गो ओपन माय स्टार्टअप, डोंट डू दिस। इंडस्ट्री इज नॉट समथिंग अब ये बहुत इंडस्ट्री चैलेंजिंग हो चुकी है। 2 व्हीलर भी, 3 व्हीलर, रेट्रोफिटिंग भी आप खोल लेंगे। बट आई टोल्ड यू, जितना मैंने आपको अभी तक बताया, ये जब मैंने शुरू किया था मुझे नहीं पता था, मुझे तो कुछ नहीं पता था कि कंप्लायंसेस क्या होते हैं, आर्किटेक्चर के। तो कर करके सीखा, और अभी भी सीख ही रहे हैं। मैं इसलिए कहा कि मैं 10% ही शायद ईवी के बारे में समझता हूँ और जानता हूँ। बहुत बड़ा सब्जेक्ट है। और जब आप देखिए, कॉलेज प्रोजेक्ट इज समथिंग व्हिच यू कैन मेक व्हेन यू कम एट द कस्टमर। आपको गालियां भी खानी पड़ती हैं। So it's a better to work with the companies like DIYguru is a very good platform from where you can have placements and all. From there you can connect with the industry and make yourself Harshad Mehta of that industry.
Okay, thank you.
Thank you.
I have a small question if I can.
Sure, definitely.
So first of all, thank you, Jawad. Thank you, Lavisha, and everyone at DIYguru. And I'm already a student with you. So my question is about the crane, the F-150 crane. You have been like retrofitting. So I know that the like the compressor needs like the motor, the diesel motor to be all the time on to feed it, like to feed the hydraulics and stuff. So how did you tackle this? Like how did you deal with this? Do you like plug in the crane all the time to electricity, or do you have like something to deal with this?
Sure. Thank you, David, for the beautiful question. Thanks. So basically what we do is that, when I said that one motor is running, giving a traction to the whole vehicle, it is moving the vehicle, and it is also working, lifting the boom also. The compressor hydraulics basically there. So there is one reducer there. When you plug that reducer, it gets disconnected from the tires, like with the powertrain, and it gives power to the boom. And yes, the motor has to run continuously, but there one challenge which came with us is that to run the motor at the exact RPM, because when you lift the load, you need the higher RPM. It's same with the engine also. So for that we have to integrate one electronic device there which sense the load, and as per that it increase the RPM of the motor, and which helps in lifting the weight.
Thank you very much. Thank you.
Thank you. There is, I can see 4 questions from Rafiq. That is retrofitting being neglected by government. Yes, definitely it is neglected, because it is something industry which I can say very good industry, but currently it is neglected. But people, government are thinking on this, because look, Rafiq, nobody has done till now has shown the result to the government, and everybody is saying sir reduce the tax, reduce this. ऐसे नहीं होता है। जब तक आप रिजल्ट्स नहीं दिखाएंगे तब तक काम नहीं होगा। And why there is no subsidy for the retrofitting? Because nobody has ever shown the result. जब तक आप रिजल्ट नहीं दिखाओगे तो आप पापा को बोल दो कि बचपन में कहते थे ना कि मुझे साइकिल चाहिए, तो व्हाट दे सेड कि फर्स्ट आ जाओ 10th में, तो यहाँ पे भी सेम है, जब तक आप रिजल्ट नहीं दिखाओगे कि इसका इम्पैक्ट कितना है तो सब्सिडी कहाँ से होगी. बट नाउ द गुड पार्ट इज वी हैड अ मीटिंग विद दिल्ली गवर्नमेंट एंड दे आर प्रोवाइडिंग सब्सिडी ऑन द retrofitment. Even Hyderabad is also providing, Telangana. Government is coming with this scheme. Why doesn't government standardize retrofit for all the available model? This is really the question, even we had put it in front of the ministry also, but मुझे लगता है कि करने से ही होगा, और जितना हम करेंगे वैसे ही रिजल्ट दिखेंगे. क्योंकि अभी मैं बात करते हैं, अगर कोई भी, मतलब मैं क्या बात करूं, कोई भी ऐसा प्लेयर, रेट्रोफिटिंग प्लेयर जो है, अगर अपना प्रपोजल गवर्नमेंट के आगे रखता है कि आप स्टैंडर्डाइज कर दो रेट्रोफिट्स को, सारे मॉडल्स, या फीस कम लो, तो अभी कोई मतलब नहीं बनता है. क्योंकि जब तक हम रिजल्ट्स नहीं दिखाएं, जब तक हम एक प्रूवन ट्रैक रिकॉर्ड नहीं दिखाएं, तभी गवर्नमेंट में सीरियसली लेगी. इज रेट्रोफिटिंग अ प्रॉफिटेबल बिजनेस? डेफिनेटली इट इज अ प्रॉफिटेबल बिजनेस, बट इट इज द बिजनेस इन विच यू बिकम द डिफॉल्ट OEM. सो ये बिजनेस बिल्कुल प्रॉफिटेबल है. हाँ, उतना ज्यादा नहीं है कि जितना आप सोच रहे होंगे एक नए OEM को मिलता है, लेकिन आप उतना ज्यादा बना सकते हैं. उसका रीजन है टू स्टैंडर्डाइज द थिंग्स, टू work on your whole system to make it profitable, because चीजें profitable बनती हैं बनाने से. और yes, आप उतना ज्यादा उसके अंदर, मतलब आप वॉल्यूम ऑफ स्केल के ऊपर इसके ऊपर खेल सकते हैं, एक दो गाड़ियों के ऊपर. there is no sense. Any other buddy? I hope I give answer to the every question. And
sir,
I think
सर,
Rahul.
मार्केट में सर जो हीरो स्प्लेंडर की रेट्रोफिटिंग किट आ रही है सर, वो कितनी रिलायबल है सर?
जी
बताएंगे उसके बारे में?
आई थिंक वो गोगो A1 पुणे के जो हैं वो बेच रहे हैं, राइट?
यस सर.
राहुल जी, बड़ा सिंपल क्वेश्चन आपसे पूछूंगा. आपके पास स्प्लेंडर, आप स्प्लेंडर लेते कितने? आई थिंक 1,75,000 की आती है कि 80,000 की आती है? कितने की आती है ना? 80,000 ना. और राहुल जी, उसके अंदर मैं आपको कहता हूँ कि आप इसके अंदर रेट्रोफिटेड किट लगा दीजिए 90,000 की. डज इट मेक अ सेंस?
यस सर, राइट.
तो बात ही खत्म. रिलायबिलिटी तो बात तब पहुंचती है जब मैं उसको पहले इकोनॉमिकली तो जस्टिफाई करूं. मैं 50,000 की चाइनीज स्कूटी खरीद लूं, मैं 90,000 में एथर ले लूं, ओला ले लूं. सो इफ यू आर हैविंग अ बेटर ऑफ इन द मार्केट, व्हाई यू गो विद द रेट्रोफिटमेंट? आई टोल्ड यू इन द स्टार्टिंग, यू हैव टू चूज द मार्केट वेरी वाइजली. मैं किस सेगमेंट के ऊपर काम कर रहा हूँ. अब मान लीजिए अगर मैं ट्रक को इलेक्ट्रिक करता हूँ, एक लाइक वी हैड अ अपॉर्चुनिटी फ्रॉम बिरला ग्रुप्स, जहाँ पे उनके दिन का 25 लाख रुपए का डीजल चलता है, और अगर वो अपने उन ट्रक्स को इलेक्ट्रिक करते हैं, अपना कैपिटल लगाते हैं, तो उनके हर दिन का जो बजट है डीजल की, वो है आपकी कुछ नहीं इलेक्ट्रिसिटी काट के, सारा मेंटेनेंस काट के आपके 22 लाख रुपए हर दिन के बच रहे हैं, इवन उससे भी ज्यादा. तो उस मार्केट को टारगेट करें जहां पे प्रॉब्लम वाकई है. आप स्प्लेंडर जो चला रहे हैं, वो 90,000 रुपए आपको स्प्लेंडर इलेक्ट्रिक करने के देगा. तो चूज योर मार्केट एंड कस्टमर वेरी वाइजली.
ओके सर.
मनीष जी, आपने हाथ रेज किया है. मनीष साहू. I think Lavisha ji, there is no other person for.
Sir, I just texted you something.
Let me just.
Can you please pardon the question? Can you please come back?
Modification that you make to make a button major, how you to apply to make it trusted branding where people feel it. Yes, definitely, Vishnu. It is definitely like modification that you make to vehicles, but a major one. How do you plan to look? Branding. Trustworthy. It always become with your work and with your choice of the components. And brand is not built in a one day. And if I talk about that, we went to that place. There we find the bearing. The experience we were sharing. And we spend our almost 30,000-40,000 rupees, on a single person. So that is how you make your brand, how you make your people trustworthy. Because, that is our fault. We have not taken care of these things in the starting, in the table. So component, first of all, the standard of quality of the material, the quality of the component and the quality of the approach, even the process you have to define in the starting. And then when your work is in the market, then your action speaks, and then your brand becomes some kind of trustworthy, and people start if Tadpole is getting repeated order every month, I think we are on that way.
Yeah. Thank you, sir. Thank you for the session.
Thank you, Vishnu. All right, I think all the questions are clear. If you have any question, feel free to approach me.
I guess it's been quite late time for Mr. Jawad also.
Yeah, even my back is hurting now.
Yes, even our team is working till now. So I guess we should wrap up the session as of now. We'll be definitely planning this once again. And it was a lovely session. Like students are not ready to leave. It's getting too interesting.
Thank you so much. I hope I just give you my whatever the best I can.
Yeah, I've shared the LinkedIn IDs of you, of me, and of DIYguru. They can directly connect to us. You can connect with me as Lavisha Basantani and by Jawad Khan to him, and you can directly inbox us.
Sure, you can send the PPT. Lavisha ji or Shubham ji is having. I have shared him the PPT. I will share him the revised version, and if anybody need, you can send accordingly. Please contact the DIYguru team for the PPT. It is
Sure, Jawad. Sure, Jawad. Thank you for your time, Jawad. I think this was one of the most interactive session we have ever had.
Thank you.
I hope everyone liked it.
Thank you.
So guys, for update, we are on next Sunday. We are organizing one more session like this. I'll share the update for the topics and all. Thank you, guys. And we are starting a batch for placement oriented course, specialization course. If anyone required for such kind of training, do let us know. All the information, contact related details already been shared in the chat box. You guys can feel free to reach us. Thank you, Jawad. Thank you everyone for joining the session.
Good night.
Thank you, Lavisha. Thank you for your time. Good night, everyone.
Thank you. Thank you.
Have a good night, everyone.
Take care.
Bye-bye.
Bye. Good night.
Good night.
Good night.
Bye. Thank you. Bye.